Alright, this morning we're on our way to Scott's at Northtown. We're going to do some work on the 3126. I know we've done lots of time-lapse videos on the machining process. We're going to dig even deeper into this one and talk about polishing crank and clearances and installing some total seal piston rings. It's going to be a good day, except I'm already 23 minutes late, so hopefully he doesn't fire me before I start. That's right, we got a King Ranch full interior. Oh, when you get a transmission back and it's got your name on it, along with who built it.
We're gonna start off by chamfering the oil galleries in the crank. We'll start installing cap and rings and put as many pistons as we can before what you have to go in what, I don't know, 10 minutes? Yeah. Okay, welcome back to Northtown Machine. This is where everything, all the magic happens. It's just a small shop, just myself. I have one other guy, my guy Aaron. He's over there doing some 350 rods. You guys have already seen the video of DeBoss and us tearing down the cat engine. Now that all the tear down is done, we're gonna be going on to machining it. So we'll be hitting all our different centers. We'll start off hot tanking it and cleaning it and prepping it, checking for all our sizes. Then we'll deck it square to the crank and then hone it, deglaze it, whatever it calls for, and then we'll start getting ready to assemble it. I have a plan for DeBoss to come in, and I'm gonna teach him to start doing some stuff on the crank. We're gonna start by chamfering all the oil gallery parts in the crank, and then I'm gonna have him polish it, and then install, and then we're gonna install rods, gap the rings, and do as much on the bottom end as we can.
Finished prepping it to put the block on. And I'm gonna set the machine, anchor the block down. Check to see if it's out at all using the little dial indicator. And if it's all good, then resurface it. The block is all anchored down, there and there. Only need 2. And now we're just testing to make sure, see if the block is level.
You're late.
I know. I'm not used to being an employee.
I got a good day planned for you.
Right on.
We're gonna start off by chamfering the oil galleries in the crank.
Okay.
We're gonna polish the crank. We'll check it for sizes. You're gonna help me carry it in because I can't put it in by myself. Takes 2 of us.
Don't you work out?
No, not really. This just looks. And this. And then we're gonna move on to the rods. We're gonna check rods for sizes. I've already done it all, but I just wanted you to go over with me.
Okay.
And then we'll start installing gapping rings and put as many pistons as we can before what you have to go in what? I don't know. 10 minutes?
Yeah. Let's go.
I'm gonna teach you how to polish and what prep work goes into getting a crank ready to get installed. This is basically how it came out of the engine when we tore it down. So those spots and stuff, that's from when it was sitting in the engine.
Yeah.
There was definitely water in it because if you look at the bottom of the water oil pan, you can see that there was a little bit of a water level. And I think it was sitting outside for a long period.
Probably.
So what we're gonna do is I'm gonna start off by getting you to chamfer. It is a little bit tricky for when you first start to get the oval into it, but I'm sure you'll pick up on it no problem. So we'll chamfer all the holes. We're gonna polish it. It's not gonna clean up everything. We're gonna get staining, but staining is nothing. As long as your bike's round and no imperfections, chances are we're probably not gonna get some of this stuff out. But again, they're gonna use a cork belt to take any of the rust, any of the debris off. If this was heavily rusted and heavily pitted, well, obviously we're gonna grind it. I get a lot of people that automatically assume polishing the belt is to make it as shiny and as smooth as possible, but that's not necessarily the case. You shouldn't rotate a crank counterclockwise when it's a clockwise rotation engine.
Yep.
And this is why. So when you polish up a crank, after it's been running in an engine for a long period of time, it's taking all these little tiny fiber hairs. Imagine if you had a microscope and there's millions and millions of all these tiny little hairs. And no matter what happens, when you grind it with a crank grinder, it opens up these pores and these hairs that are in the crank. When we polish it, what we're doing is we're multiplying that. So there's 10 times or 1,000,000 times more of those hairs, and they're all in the direction of the way we polish it. You do a couple of revolutions on a fresh polished crank. In reverse, if you take that bearing cap off, that oil now will be gray because it's actually picking up some of that bearing material. So when we polish it, what we're actually doing is we want those fibers in there because that's what suspends and grips the oil to the crank and allows the crank to float. It's not supposed to touch the bearings, it's supposed to ride on the oil film, and the polish allows that to happen. So what we're going to do is we're going to start off by chamfering all these holes. It's pretty simple, just use a little tiny die grinder with a little bit. There is some pretty good chamfers in here already. I won't get you to do the main oil gallery holes.
Okay.
What we'll do is we'll play a little bit with the rod. Now this isn't bad. You can see a light chamfer halfway around it.
Yeah.
But you can see a tight side on here.
Yeah.
I want to get rid of that because when we go in and brush all our oil galleries out with our brushes, in some cases, pulling that brush out is enough just to pull up a little tiny piece of steel and would create a high spot or something to scratch your bearing on. Okay, so what we're going to do is we're going to go in and we're going to take those sharp edges off, blend them into what already the chamfer is already there, and then we'll brush out our cranks with no risk of pulling material up.
Okay.
And then we'll polish the crank after.
Okay. Will that help as with the oil coming out too, because it's sharp here and chamfered on one side? If the oil's coming out, would it favor the oil going one way and not the other?
Not really, no.
No?
It's
okay.
all coming out at such a speed. I'm more concerned just about any type of small bits that can get pulled back out.
Okay.
If we got into actually fish mouthing or grooving these oil galleries and creating a path for it, then yeah, and that's where you start to get into some performance engines, wide mouth oil galleries. That's not what we're going to be doing.
Okay.
We're just eliminating any future problems.
Okay.
So basically all it is it's just like chamfering any type of hole, but this hole is oval, so it's going to want to catch on you and go across.
Okay.
Obviously, we don't want to bounce all the way across. Hopefully it won't happen, but it's just simple. We just want to do, I try to support it with my one hand. I usually try to let it fall into the circle. There we go. So you can see the nice crisp chamfer all the way across now.
Yeah.
That's all we're looking for. Try to cup the stone right into the hole and kind of go, yeah, just like that.
Okay.
Perfect.
Yeah.
If it blows a rod on number 4, we know it's that was your first one. It's a little bit harder from the opposite side, eh? Yeah. That looks good.
That's enough?
Yep.
Okay.
We'll go over this one, number 5. Oh! Yeah, it looks good. Number 6.
You did that one or no?
Nope, that's yours. You got that one. Yeah, I think you got them all.
Right on.
Good job. You can feel the stone drops right in.
Yeah, yeah.
You can kind of just, you start getting the smaller like Hondas, even Ford 302. Man, they're hard. You can really jump off the hole really fast, right? Right across the rods or vanes. Okay, so we're gonna set this thing up now. We're gonna polish. I always like to go with my cranks. I go with a little bit of a used belt first, just to knock down any of
the high spot.
dirty grip.
Yeah.
There's no point in wrecking a brand new belt on cutting all that stuff down. So we're just gonna hit it with a used belt, and right after that used belt, we're gonna throw a new belt on, redo the whole thing.
Okay.
So on a big crank like this, you really shouldn't have any problem. But what you don't want to do as it's spinning, you don't want to have tension and then no tension. You don't want to be on a down to be loose, and then on the up, it go really tight.
Yeah.
You want to try to move your arm with it, with the stroke, so you keep the same tension all the way across. Don't worry if you mess up a couple times. Another reason why I have a used belt on it, but a cork belt is not designed to remove material.
Okay.
It will only polish it.
Okay. It won't turn into an egg.
If we held it there for all day long, but you're going to hit it once, it's going to get tension, it's not going to cause any problems for you. I'll show you the main, I'll show you a rod,
Yep.
and we'll let you continue on.
All right.
That happens sometimes too. That'll get cut out, right?
Yeah.
Okay, so I just put a little bit of tension on this because sometimes I have the habit of breaking it off. It's up, set this up. Pretty simple. When I start to lower down the main, you'll start to see the tension come up. It's not really doing much, only because it's an older belt. Pretty simple, right?
Yeah.
Okay, so we'll go to a rod. So now we have to offset the table to line up. So we time it right, so we come down on the downstroke of it. All right, yep. And then we just rock with the stroke of the crank. Yeah. And as it's going around, we just want to pull over just a little bit. Now we're going over top of the oil gallery. That's why you hear that miss. Yeah. I come over the edge. It's going to be a little bit harder for you to know where the edge is. I just been doing it for so long so I can have the feel of the machine.
Yeah.
So you can see how I maintain this gap here all the time.
Yeah.
So that's the tension. If I don't move it, this is what happens, see?
Yeah.
Yeah. You don't want that.
Yeah.
We don't want to put a lot of tension on it. All we're doing is just hitting that surface. See the glow around the oil hole? Yeah. It's just in my personal opinion. That's for the pressures of drilling the oil gallery out.
Right.
It has to displace material when you're doing that.
Yeah, yeah.
So that's just a little bit of deflection. It's probably less than a tenth.
Yeah.
But you start to see those marks, right?
Yeah.
So what do you think? You ready?
Yep, I'm ready.
Flick that so we get rotation.
Yeah. This one?
Yep. You can do a main or a rod first?
I'll do
Maybe.
main.
Yeah, try main first.
Yeah, no, just getting the feel for the machine.
So can you feel how it rolls back and forth?
Yeah.
Yeah, there you go. All right, you can turn it on. That's pretty good. I heard it bottom out there for a second, but there you go. That's a little better. You just got to get in time with it, that's all. You kind of just watch that gap on the belt and try to maintain that tension on it. Perfect. Let's stop it and see. Yeah, there you go. So you see a little line like that right there?
Yeah.
Nothing to worry about. The crank is such high quality. You just see how shiny and brilliant it's standing out, right?
Right.
The camera doesn't do it justice. You can see our reflection in it almost.
Yeah, yeah.
But yeah, little lines like that, nothing.
Like all the water spots are gone.
Yeah.
Except for the one where you broke the belt here.
Yeah. So the smaller belts are obviously for smaller journals, right?
Yeah.
So I'm going to give you a little bit larger belt. So now you'll only have to do half the movement.
Yeah.
Okay? Some of these lines and some of these pittings, it's not going to hurt because surface area for one.
Yeah.
It's not all the way around the journal. It's only in one spot.
Yeah.
And traditionally, by standard, it's holding oil.
Yeah.
It's just a spot
Yeah.
to hold oil.
Yeah.
And that's what, in the trade, that's what people will make fun of. They'll just hold oil, right? But that's not even, it looks like a line, but you wouldn't even be able to measure it. It's just because the polish isn't digging down and taking that out, right?
Right.
If we were to put a sanding belt on, like an actual belt to remove material,
Yeah.
you would get rid of all of this. But that's not what we want.
Okay.
We don't want to remove material for one.
Yeah.
There's nothing wrong with this crank. By measurements, this crank is 100% perfect. All we're doing is open up the pores again and making it clean so you don't have any dirt.
Yeah.
And it had a little bit of rust on it, but I don't know if you can pick that up on the camera. Without grinding, you're not going to get rid of some of these marks.
I think they're gone.
You can just see it. You won't be able to see it in the camera. You can just see some tiny leftover.
Oh yeah, one little line there. Yeah, but we're going over it with another belt
probably,
again too, right?
It was sitting for so long that where that moisture is going to collect.
Yeah,
Right?
shoot.
Even in a sealed engine, it's still going to collect moisture in our climate because of winters and summers. Like this morning, it was like 11, and it'll get to 30.
Yeah.
That creates moisture. Absolutely nothing wrong with it. No problem.
Because now we're gonna clean all the oil galleries, make sure there's nothing in there.
So what I use is, I'm a big fan of gun wash. So basically just like a painter, auto body guy, this is the same, they call it thinners. But the next step, it's a cleaner version of thinners, which is a gun wash, and it doesn't leave any residue back. Cuts, grease, and oil. Unbelievable.
Nice.
So basically I just go off.
Gun wash meant for cleaning guns?
Paint.
Oh, paint guns, all right.
So we go find the right brush. So we'll get one that just has a little bit of tension on it. So this is what I was talking to you about earlier, and this is why we chamfer the holes. Because when we go bring our brush in, so you can see how the edge of the brush is hitting on the oil gallery.
Yeah.
Well, most people won't even care.
Yeah.
Just yank that out. If this has a sharp edge on it, when I go to take it out, it's going to peel that edge up, and that's why I get a high spot.
Right.
I still take my time, and I pull it out through the center so it's not touching.
Yeah.
But it's just the little things that count. So now what I do is I'll fill each hole, and I'll brush out, and I can feel if there's a chunk, and you can see a little bit of dirt. Now this particular crank has already been hot tanked twice, and all the gallery plugs have been brushed out. But we're doing it again just to be 100% sure. There's still a lot of dust that will come out.
Yeah.
But this will be the finished product off this. I will not hot tank this again after.
Okay.
This will be more than enough than what it needs. There won't be any dust left. And we do all through holes. All these rod journals connect with the central main oil gallery. Normal blow gun, but copper end. Copper end won't scratch any of the steel or any of that, so I can stick it right in the hole. It's not going to scratch up the steel. I usually go on the back side and make sure that air is coming out. So I'm done with that. Now I take a clean, brand new rag. Now that thinners will leave a little bit of a residue, especially if they're pulling out a little bit of dirt. I buy special rags that are these have the static removed from them, so they don't have lint that builds up on them.
Okay.
And it looks crude, but this is the best way to do it. Keeps it clean. Typically after this, I would bag it all up with saran wrap and seal everything off. There's no oils, there's no water, there's nothing on it, so it would not rust. It won't corrode or that stuff.
You don't gob a tube of grease on there?
And that's how I know it's sitting. But our jobs don't sit. I'm either installing it or the customer's waiting on it.
Yeah.
If the customer says, yeah, it's going to sit for a long time.
Difference between diesel engines and hot rod engines
they
where,
don't sit.
yeah.
So now I give it one more little blast of air just to... That crank is ready to install. So this is my Bible. This is a Molly bearing book. So this pretty well gives us as much information that we need to build an engine, specs, everything to follow. So in this, it's...
You don't randomly Google stuff and watch YouTube videos and what the specs are?
Mostly the box videos, 3126, 3126B, 3126C, all has the same line code. In some cases, I can even go into different series and look for that line code, and it'll refer back to it. A lot of the engines are all the same and have the same specs. But we're going to go with this one. This one's number 7. So we just find number 7 in our book. That's right here. You see 3116, same. 3126B, C, E, turbocharged, intercooled. 3126 generic 7.2 liter, and this now gives us our rod bearings, the bearings that we should be using, the oversizes, standard shaft diameters, bearing housing. This is our Bible. Okay.
Nice.
So we're going to start setting up, and we're going to start going over some of these specs. So right now what we're looking for is we're going to double check. I've already done all this stuff, but with you being here, I want to give you the experience of doing it. So what we're going to do is we're going to check the housing bore. I just set it up. I set my bore gauge, go inside, check and make sure it's to the right spec. In this case, we were doing, it didn't have a lot of time on it. If I get an engine that comes in that has 300,000, 400,000, 500,000 kilometers, I would cut all these rods and resize back to standard size.
Cut meaning you take a little chunk out in between and then bore it out?
Yeah, we'd cut a little bit of material off the rod, a little bit off the cap. That essentially brings that circle now to an oval, and then we resize the center hole back to a circle to our specs that they give us in the book.
Okay.
Now, technically, that does drop our center line of the rod, which means that it lowers our compression distance.
Yeah.
Very, very minutely, almost, I would say maybe 1 to 2, maybe 3 thou at the most, if the rods are in good condition like this. But you'll see when we do the build, we're going to install all this stuff, we're going to check our piston heights, and we're going to cut all our pistons to the proper height. That's what I do as a standard job. Some people can just slap this together, and 99% of people do. But I want to make sure that this piston is the same as this piston is the same as this piston. We do the same thing with the valves. Every single valve is cut to the same depth, and that gives you equality through your engine. And every one of our engines is done the exact same way, even to the point when we deck a block, it's squared to the center line of the crank.
Yeah.
So we know that the front is squared to the back. So there's 2 important numbers that we need to see. We need to have our bearing outside diameter, or housing bore. So the housing bore is what we need. Our housing bore diameter, like we follow right down to here. So that gives us a difference of 2.9523 to 2.9533. So you can see that we're allowed to have a thou of difference. And then what we also want to know is our max wall. So I check this on every single bearing that I install into an engine. So you go down to our max wall is 97.097. And what that means is you take a rod bearing, and that's measuring the thickness of the bearing. And I check every single bearing because I have gotten in situations where they're off or they've been mismatched in the packaging. But this is crucial to our build. What I'm going to do is I want to make sure that I'm not over top of this number. So what I typically do is I'll take the 2-inch 953, set my mic, set my bore gauge, and then we want to be below that. So as long as we're tighter than that, I'm happy with it. So what we do is we take our bore gauge, lightly knock that down. I set my mic. Now this mic has been zeroed. I zero it once a week at least. We set our mic to the 2-inch 953. We're going to adjust our bore gauge. Try to get it right at the very top there. Okay, once it's set, we'll lock it down. Get our rod. Nice. Set down our rod. And now I just support it on the bottom so I know where my zero is. You can see right on zero. Nice. And we'll check all the way through across the whole surface to make sure that we're in. And we are perfect. Then we'll go across, we'll check every rod just like that. We're going to do cam bearings. Going inside and just wiping out, just make sure it just came out of the hot tank. So everything is clean on it, but I still want to just make sure I have no type of dust or anything that might be floating around at this time. So everything's clean. So I printed this off of AERA, which I'm a member of. It's an engine rebuilding association that's American based, and they basically have information for pretty well every engine that's out there. And there's a special service bulletin in regards to the installation of the cam bearings. There's lots of confusion. You would assume that the oil gallery hole would line up with the oil gallery hole in the block, but with these being a full groove bearing, that would almost eliminate any oil pressure getting anywhere else, because there would be a free flow straight through that hole and very little would come around the groove. So what they're doing is, what they're telling us is that they want the parting line at roughly 3 o'clock and then the oil hole pointing straight up. So now that will force that oil to go in around the oil bearings or the groove. Then that hole will come out and lubricate the cam. Alright, so we have all our cam bearings set out. All of them are the same except for the front one. The front one's a different one. So, but what I like to do is, I like to always start in the middle. So what we're going to do is we're going to install the first 3, or the middle 3. Then we're going to install the cam, make sure it spins freely, and that will get to our starting point. And then we'll start to do a cam bearing out. We'll do one more cam bearing, install the cam again, make sure it moves freely, another cam bearing, and we'll have a feel for it. I like to fit cams and try to fit the cams so that it can rotate freely without lubrication. Because then I know with lubrication, it'll spin freely.
Yeah.
Now this will come down to, these are babbitt bearings. I try to install babbitt bearings in every possible location that I can.
Yeah.
So install that. We're going to start with the center one. Guide line is right there. We'll pull this up. So you can see in the hole that it's not lined up because the rocker box goes here too. So that groove also has to feed this hole. So we're just going to install it until that groove lines up that hole.
That's it.
Next one. You want to try it?
I can try it.
So we'll go down to installing the main bearings in. What I do is I go back to my trusty old book here. So now we're on the main bearings, and what I want to know is I want to know the max wall on the main bearings. So because this is a standard bearing, this will give us the standard thickness of it. And so what it is, it's 96 thou and 8/10. So there's a special ball mic that goes on here. It's rounded on one side so that you can get into the curve of the bearing. And now we'll go across and we'll measure all the bearings. We know the crank is standard. We're at 96 and a half. And it calls for 96 and 8/10. And typically in aftermarket bearings, they always give you a couple tenths extra of clearance.
Okay.
We know the crank is standard, and this will mic up as a standard bearing. So now we go across, and I mic every single one of them to make sure that we have the same. In some cases, if we have ones that are off a little bit, we can mix and match and make sure that we match them up to ones that have maybe more material. That's very rare though. In today's age with machining, most of the parts are bang on. So just mic up every single main. They've already been wiped down. Just to mention too that we previously magnafluxed cylinders, magnafluxed the side of the block to make sure there's no cracks or anything in it. And we've also bolted on all the main caps and measured the housing bore to make sure that it's within specs too. So all that work has already been done. It's a lot of work to get all on video all the time. But we know that the block itself is perfect. All our main bearings are perfect. We've already mic'd the crank. We know the crank is perfect. So now we just drop the bearings in
So
for the crank.
you take your housing bore, minus the width of the bearing, subtract the width of the crank journal, and that'll give you your clearance.
In a little bit of math like that, yeah.
So these are solid on one and a hole in the other.
Yeah.
If you do them backwards, it runs for about 30 seconds
Yeah.
before it seizes up.
The grooves should be offset so you can't install them backwards.
Yeah. Well, we had a guy put a 3406 together that seized up in about 30 seconds.
Really?
Yep.
That was before me, right?
That was at Egger Trucker Machine.
Really?
Yeah, he didn't last very long. And no, it wasn't me.
You see the locks. The locks are only there. They're foolproof. Really, you don't need the locks there, and there's a lot of older engines that don't even have any locks on it. And I'm sure I'll probably get some comments about that, but the locks are really only for the installer. That lock doesn't hold the bearing. The crush on the housing bore is what holds the bearing. If the bearing spins, you have to resize the rod or line bore the block, because if it's spun in there, it's lost the crush. And it's not because of those tabs have nothing to do.
That's a very that's a very definitive answer.
I'm sure I'll get people saying stuff, but you can talk to bearing manufacturers. This is one thing I'm adamant about.
Okay, then we'll leave that on camera.
Yeah.
Comment down below as to how wrong Scott is.
This is my product of choice. I've been using this stuff now for about 14, 15 years. Even before that, it's a Clevite bearing guard and a Clevite cam lobe guard. So this has your ZDP and your molybdenum and all that in that. It sticks to the cam for break-in. I've never had this let me down. I use it for every single engine, anywhere from 5 to 8 engines a month, heavy industrial and diesel.
Oh, that's exciting.
I love any engine that has the seals that bolt on after, because then we already know the math, everything's good. Now we just drop it on. So there are arrows on the front of the cap and numbered.
Towards the front.
Yeah, and if you ever get into a situation, what I typically do, and there's a lot of engines I have to do this, but you can look in the block and you can see the shadow. You can see the staining of it from having it before.
Right.
And in industry standard, it's not always the rule, but locks usually always go together.
45 plus 90 degrees.
Now you gotta be a little bit careful with this assembly lube. It is a thicker grease, so it does feel a little bit sticky. And after experience, you know what it feels like. And sometimes right off the start, you gotta get it going because you need to break that seal between the thick grease. So what we're gonna do is we're gonna torque 1, 2, 3, 4, 5. We're gonna leave thrust out, go to 7, make sure it spins nice. Every time we torque one, we'll spin it to make sure it feels good. For some reason, if it tightens up, we'll know it's that main that tightens up instead of doing it all and then come back and check. And then we're going to set our thrust.
So you don't start in the middle and work your way out?
No, this crank shouldn't be touching those bearings in the top right now.
Okay.
Because there is a clearance for about 3.5 thou clearance.
Okay.
So by the math, it won't be touching, and once this engine starts and oil pressure gets up, it's not touching.
Right.
It runs on the bed of oil.
Okay.
Now heads are a different story. So now we're going to set the thrust. It's not too big on this one because you usually set the thrust when the upper and the lower have the same thrust bearing. So that's a flange all the way around. This is only a half flanged bearing. So that means just the bearing that's in the block has the thrust flange on it. When you have one that's on the main cap, you need to make sure that those two flanges meet up. And I personally always use it or do it so that they align up to the pressure side of the crank. So if the engine is standard, it will be coming from the crank being pushed towards the front of the engine.
Every time you put your foot on the clutch and push the... Yeah.
A lot of people don't get that, but that crank does move. If I was to set thrust or align those bearings from the front backwards, and there happened to be an imperfection in that bearing, well, it would only touch half on the thrust, and it would wear out, and that's when you get into a situation where it burns thrust.
Yeah.
And once you burn a thrust, just not usually end up having to weld that back up and re-grind it back down. Not a situation you want to get into. This one, fortunately, we don't have to worry about that, but I'm still going to just give it a hit back and forth to make sure that bearing is in its position, and then we will check with the specs to see what the end thrust is, set up a dial indicator, and make sure that we're within that spec. Now we'll do our 90. Set up our dial indicator. Set her to 0. And now we have a little bit of movement. So we're looking about 4.5 to 5 thou thrust, 3 to 9 thou.
Right on.
Perfect. Okay, so we're installing our total seal gapless rings. This is the second groove gapless ring, and what that means is that we actually have the second ring that has a little step in it, which will install an outside ring with the gaps off 180 degrees apart, which essentially will give us a total seal ring. Well, we'll start first with our first number 1 ring. first screw. What I like to do is I just like to pop them in and just hold the ring, keep it sturdy, pop it in, flip it over. And I do all 6 at the same time. That way we don't get confused. These are keystone rings, so they have a sharp taper on both sides, which is good for exhaust gas or internal pressures to push against the ring and pop it back out. More surface area. Fingers up. So according to our specs, we're allowed anywhere from 16 to 25 thou end gap. So I like to see 2 thou above minimum. So I like to be around my 18 thou. So I have my 18 thou feeder gauge. I have my 16 thou minimum, just in case. I'll go ahead and check. We're good at 18, 18, 18. Everything's going in nice and smooth. I'll just go to my 20 thou. Just to see if 20 thou goes in, to see what we're sitting at. And 20 thou is tight. So we're sitting at about 20 thou end gap. Are you happy with that?
Yeah.
You have to live with this
Yeah.
for the rest of your life. What I do now to keep everything in order, I like to keep everything with the hole that I've tested with. So now I'll put that there. And don't worry, all this stuff gets cleaned before we pop it on. But this will ensure that I'm keeping those rings in that hole so it all goes back together properly. And now we'll move to number 2 ring. This is the gapless ring. In some cases we have to file, in some cases we don't have to file. Okay, number 3. See, these are just a scrape ring, so you can instantly feel the difference of installing them because there's no tension to them, right?
Right.
It's only sitting there to float to scrape the oil back down.
So the oil comes through the piston, out the rings, and then...
These have piston squirters on them.
Okay.
But it doesn't, the gases make it back up the side of the skirt. Some pistons you'll see with holes in through the inside, and that's to allow the gas pressure to push up against the oil ring.
Okay.
But these ones are traveling up through here, and that's why those cutaways are in that.
Okay.
And it'll work its way around the inside of the ring to expand that out. And it's only there just to scrape the oil back down off the cylinder. It's not there for any type of sealing or compression or anything like that.
That doesn't work with synthetic oils.
Yes.
They want 12 thou?
Perfect. Perfect. Just a tiny little bit of drag, but not holding me back.
Nice.
What a great kit.
Nice.
Great kit. These things are bang on.
If you want to do more research on Total Seal, you can get your own kit. This was a kit sent to us, but if you've got rear engines or anything, you can send them your rings and they will cut the groove in there and put the gapless on whatever rings you have.
So we're pretty numbered. We just like to keep everything in the same order as it came. I almost feel like this engine was a recent rebuild, but the outside of the engine you wouldn't think it was. I did take all this and clean all the ring grooves and everything on it, and then I re-etched the aluminum to bring it back to just add a coating on.
How do you do that?
I just have ashes. It's almost like gluing.
Okay.
It's meant for forged aluminum and stuff like that. That will bring these colors back in, and it's just an extra hard. It's almost like a hardness coating, almost like an anodizing for aluminum.
Okay.
You can see that it matches the color of the piston. So what we're going to do is we're going to go in. We'll install circlips on each one. It's pretty important on these circlips. Most people out there will know this. So there's always a sharp side and a dull side to a circlip. And you can just tell that by running your finger across it. You can see that that has a curved side to it. And you see that's a flat cut. Flat cut always goes out because that's what really grabs it before, right? So some people do things, have their own ways of doing stuff, but I like to always keep the clips pointing downwards.
So, have you ever heard people don't lay the pistons on their side to deform them.
I have heard stories like that, and especially with cranks, they say not to lay cranks on their side.
Yep.
It is true about cranks. If I have one that has been sitting there, our customers brought in, I can see that out of round.
Okay.
I check for straightness. Usually that, once you stand it up on its end, it'll form itself back within a day or two.
Oh, really?
I don't really understand that with a piston, because all pistons, today's pistons, are cam ground. So what that means is they're actually ground oval, because the cooling in the pin, because of the size of it, doesn't expand at the same rate.
Yeah.
So there's a lot of technology that's gone in pistons nowadays, and that these are actually machined on oval, so that when they warm up to temperature, they become round and conform to the cylinder.
Okay.
So as to leaving a piston, I typically wouldn't leave a piston sitting on the side anyway, because it's going to roll away.
Yeah.
And there's a perfect, nice flat surface right there to sit it on. It gets a little bit tricky. I have pin-honed all these. After an engine has ran for a long period of time, it will have marks and burrs, especially for taking these circlips out. You will get some little burrs in there too, so the piston will slide through.
Yep.
So I've put it in the machine and I've pin-honed with all my machine to make sure that those pins all slide back forward nicely. But to actually get that first initial square, it does get a little tricky sometimes. And sometimes it'll just be a pain in the butt and I won't get it, and I might have to go back and put it in the machine again. But for the most part, it should slide nice and easy. If that pin doesn't slide in there nice and easy, then you have problems. Both the pin and the rod should move freely on themselves. You should never have to use a hammer to put the pin in, or into the piston, or into the rod. Even in applications like dirt bikes and four-wheelers and stuff like that, only time that is an issue is when it's a pressed piston. So you press the pin into the rod on, say, a typical 350 Chevy or a Ford 302. They still float on the piston. So those pins still have to move nice and freely on that piston. If they don't, you're going to have half the amount of time on the rod bearing, because it's always stressing to go to the direction of thrust. If it doesn't move freely, then you're in big trouble. Cut the life in half if you even get it on the road. I do watch people on YouTube that install some stuff with soft hammers and installing the pins with soft hammers, but I never make comments. Because it's a tapered housing, you kind of have to rock. Yeah, see how nice it goes in?
It's
nice and
so
slow.
nice.
No problems. Find a sharp edge. My hands are covered in this grease now. Everyone's clinging everywhere. They give it a little extra squeeze and just make sure it rocks inside that groove. You can feel it when it pops in, but I also want that clip to move freely too, right? Because for some reason, if something's jamming up, it could be a reason for the pin to jam up. And if it doesn't get the proper rock, it can blow out rod bearings fast. There we go. Now it's rings. There's lots of different theories out there, and there's lots of different ways of doing stuff. I'm not saying one doesn't work or one does work. We will lube these up, the rings and everything, very good. I do know some people that dunk them and all that first, but I traditionally do I don't want to have everything all over the place. So I do a dry run first, a dry assembly, because I want to check all my heights of the pistons, and if there is an issue with a piston sitting too high or too low, I can measure the pistons and cut the pistons to make sure they all match. So right now we're just going to throw a set of rings on, and typically when I install an engine, I just cover everything with oil. I don't have necessarily dunk them or soak them in a tub or anything like that. I do use a generous amount of oil before install. But what we're going to try is we're going to try some of that new Total Seal ring lube.
I always put the gap on one side, the opposite gap on the other side.
Yep. Okay, so put the second ring on. Now we're just going to start our groove from this side.
So step is down and the second part of the ring is on the bottom.
Yep. And they are tricky. We may have to do this a couple times, but we just put it underneath the groove there and kind of start it. But then I find if we roll the whole ring into the groove while we're bringing it around. We gotta try to keep it up. And really inspect that it stayed up on top of the rail.
If it slips past the groove, you're gonna have some issues, yeah.
Yeah, well, but we should be able to just bring our fingernail and bring it up across. But right now it looks like it's okay. It moves nice and freely.
Nice.
So, then we just do a top ring.
Top ring.
Yeah, it is labeled the top as well. That's it.
Nice. Welcome to the rust belt.
Needs to be 20 thou. Perfect. The range they gave me was 20 to 30 thou. It's at 27.
All right, if you remember our Everything Wrong with 3126 video, we talked about the gasket in between the oil filter housing and the cooler. They like to blow out in between and send your unfiltered oil directly to the HUE system, and that's with the old felt gaskets. They have a little silicone ring on there, but even still, these have been updated by CAT for a steel one. That in turn makes it last so that your unfiltered oil doesn't go all through your HUE system, which gets expensive. So we also got the steel one between the oil cooler and the engine block. So one more thing to bulletproof our engine. I have some gaskets for sale. If you want those, Scott, you can put those on eBay or whatever you want.
Oh, you kinked it.
It's still good. Stick it.
There we go. For sale.
right, so I'm an official Northtown employee now because I'm wearing a shirt. But I took my 2-week vacation because I'm allowed my vacation time. That's my right.
Yeah, you paid into it.
So what'd you do while I was gone, huh?
Basically did the full assembly, got everything together. You were here to check everything out with me, tap the rings.
So you put the pistons in dry just to measure the protrusion?
Yeah, everything was within spec. I assembled the bottom end, the rotating assembly. I put all the gapless rings on, used the Total Seal ring lube that they supply to us.
Okay.
Great product. I'm probably gonna start buying that and adding it to my inventory. And yeah, now you see it. Put the oil pump on, torqued all the rods, torqued all the mains, put the front cover on, bell housing on, and now we're onto the head.
Right on. You mentioned in the last video that there was the cam followers, those bolts were a weak point?
I thought that this was the version of engine that had that weak point. It's not. I went through a CAT service bulletin. It didn't have it for this serial number of engine.
Okay.
It's a different version of engine that I thought I just had it mixed up with a different engine.
Right on.
This is just a single shim, 1 thickness, perforated steel gasket, torqued down, good to go.
Right on. All right, so you guys know next video is going to be the head, and then we will have it back in my shop, all kind of looking pretty, yellow paint.
It's up to you. Do you want to paint it? You want me to paint it?
I think I'll paint it. Maybe you want to paint?
No, it doesn't matter.
I can come here. I'm an employee.
Yeah.
I can paint
Yeah.
it too. Where do you punch in?
Nowhere. This is a trust-based environment.
Next video is going to be the head. And lots of cool stuff going on with that. We'll get into the injectors and the cups in that one. But she's coming together, finally. So remember, if you're not filthy, you're not rich, get out there, work on it. Maybe don't get filthy when you're working on my engine, but you guys should go get filthy.
Stay clean and pour. Working it.
All right.